Good day, grade 12 learners. Welcome to today's technical mathematics lesson. My name is Matsidiso Kongwane. This lesson is brought to you by Gauteng Department of Education in collaboration with Saibono Discovery Center and broadcast by Pagama Research and Development. Our lesson for today, grade 12 learners, is on trigonometry. And then in trigonometry, we are going to look at identities, reduction formula, and equations. Remember, our WhatsApp number is 079 578 2908. Let me repeat it again. It's 079 578 2908. You are more than welcome, grade 12, to send any clarity-seeking questions to that particular number or your solution in that regard. Okay, let's continue. Right, the objectives of today's lesson. During this lesson, we will be revising the basic trig ratios as well as the reciprocal of these particular ratios. And then we will also refer to special angles in cases that we are calculating without using a calculator. And then simplify trig expressions or equations by making use of a calculator. And then we are also going to use trigonometric identities, and then we'll apply reduction formulae where necessary, and then we'll also determine the solution of trig equations within the interval where theta will lie between 0 degrees up to 360 degrees. And then lastly, we'll apply trig identities where we are proving what? The left-hand side being equal to the right-hand side. That is the objectives of today's lessons. And then let's start grade 12 with trigonometric ratios. And then with the trig ratios, remember, basically we have three ratios, which is a sine, a cos, and a tangent. Okay. And then when we are talking to sine now, we use this abbreviation here, which is so ka toa. Okay. And then this ratios, trig ratios, we only use when we are having a right angle triangle. What do we mean about that? We mean the 90 degrees triangle, grade 12. The same as the one that we are having here. For an example, there must be a 90 degrees angle within that particular triangle. It's only then that you can apply what? Your trigonometry ratios, which is sine, cos, and tangent. All right. And then now, basically, we know that if we are looking at sine theta, we are looking at the opposite over hypotenuse. For example, if I'm sitting here at theta, the sine of theta will be opposite side, which is that one over there, hypotenuse side, grade 12. And then now when we write this in terms of x, y, r, when you talk opposite, we are talking to y. When you talk hypotenuse, that is the r side. Okay. And then now looking at the cos ratio, when we look at cos, we are talking adjacent over hypotenuse. And then the adjacent side is represented by x, and the hypotenuse side is represented by r. And then with the tangent, we are having opposite over adjacent. And remember, opposite is y, as we indicated there. Y is opposite. And then the adjacent is represented by x. Grade 12. Okay, and then which side now is the hypotenuse side? The hypotenuse side, which is the r side, it is always the side that is opposite what? The angle of 90 degrees. Okay, and then the opposite side is the side that is opposite your theta angle, and then the adjacent is the one that is adjacent to the theta angle. And then now we can also bring in the Pythagoras theorem when we are using these particular trig ratios. Why Pythagoras? Because Pythagoras we can only apply in the 90 degrees triangle. Hence, we are bringing in the Pythagoras theorem, which says that the r squared is equal to x squared plus the y squared. Grade 12 only if you have a 90 degrees triangle. Okay, therefore we have our sine theta is opposite over hypotenuse, opposite is y, and the hypotenuse is r. We have the cos of theta, which is adjacent over hypotenuse. The adjacent side is the x side, and the hypotenuse is the r. And then the tan theta opposite over hypotenuse, therefore opposite is y over x. And then grade 12, if you look at this simply means now, to be able to identify your trig ratios, you will need what? You need x, you need y, you need the value of r. Therefore, you can answer any trig ratio. You can also use Pythagoras if you need to calculate one of the unknowns there. Basically, that is what we need in order to use the trig ratios. Right. And then these trig ratios now, the original three ones, they have their reciprocals. And then the reciprocals of these trig ratios are, if you look at sine, which is y over r, opposite over hypotenuse, this goes with the cosec. That means sine is equal to 1 over cosec theta. Cosec, therefore, is the reciprocal of a sine. If it is given as a cosec, you can write it as 1 over sine. Since a sine and cosec is a reciprocal of sine. Okay, grade 12. Remember, we've indicated previously that if we are talking to sine, we talk opposite over hypotenuse. Since now cosec is a reciprocal of sine, therefore it will go hypotenuse over opposite. It is swapping around whatever you were having for sine there. And then with the cos, we are having the adjacent over hypotenuse. And then what is its reciprocal? It is now a sec theta. And then now if, since this was adjacent over hypotenuse, therefore the reciprocal will take what? Hypotenuse over the adjacent. And then we are allowed to write this cos as 1 over sec, or if it was a sec, it will be written as 1 over cos in terms of its reciprocal. Moving to tangent now. With the tangent trig ratio, we are having opposite over the adjacent. And then what is the reciprocal for tangent? This is a cotangent, which is cot abbreviated. So since tangent was opposite over adjacent, therefore the cot will take what? Adjacent over the opposite. We are swapping around the ratios. And then now if you want to write time in terms of its reciprocal, it will be 1 over cot. If you want to write the cot in terms of its reciprocal, it will be what? 1 over a tangent, grade 12. Therefore, that means sine goes with cosec. A cot goes with sec. A tangent goes with a cot. Right. Now we are going to look at the first type of trigonometry application, where we are using a diagram or sketches to solve the problems. That is type 1 that we are going to look into today, grade 12. And then let's take an example on that. And then in this case, we are given that if cot alpha is equals to 2, and then for alpha being an element of 180 to 360, and then 180 and 360 is not included because the brackets are the open brackets, determine with the aid of the diagram the following ratios. And then what is the method, grade 12, before starting these types of question? Number 1, you ignore the questions. You look at what is given to you. What was given to us in terms of ratio is the cot of alpha, which is equals to 2. And then if it is 2, we know that in a fraction form, it is 2 over 1. And remember, a cot is a reciprocal of what? Of a tangent. Okay? And remember, when you look at the tangent of alpha, we will be saying this is what? Opposite over adjacent. Opposite over adjacent. Therefore, that means it is y over x. Now, because we are looking at the reciprocal, instead of being y over x, this will take what? An x over y. This indicates that now the x value is 2 and the y value is 1 for the given information. If you look at that graph, you can see that we short of the value of r in order to be able to answer all our trig ratios. And then now to find the value of r, you can't just go straight to Pythagoras. You must start by identifying the correct quadrant to solve in. Okay, how do we identify that particular quadrant? Okay, let's see now. Initially, we're given this chord being a positive chord then. Okay, it's a positive 2. Then grade 12, your first step will be identify in which quadrant is the chord positive now. Remember our cast diagram? In quadrant 1, all the ratios are positive. And then the chord, remember, goes with tangent. That means it will go in this quadrant where tan is positive. Okay, so when we are looking at the chord that is positive, we are talking to quadrant 1 and quadrant 4. But we need only 1 as our final quadrant. How are we going to finalize that now? We look at the restriction. It says alpha must lie between 180 and 360. So when we talk 180, we talk movement from that line to that one. So that means now you can see that it is excluding that quadrant 1 because the restriction says work only from 180 to 360. So that means we are in quadrant 3 and 4. Which one qualifies for both being positive and 180 to 360? That is quadrant 3. Basically, great terms. Therefore, we are going to have our sketch and y was negative. This was initially a minus 2 over a negative 1. In a simplified form, we end up with a 2 over 1, which is positive greater. So this diagram plays a major important role before we can start doing our calculation. And thereof, grade 12, we can now calculate the value of r because we are short of r there. Go Pythagoras. No diagram, no Pythagoras. We only go Pythagoras after indicating the correct quadrant on our diagram. There we are. Pythagoras, that is r squared is equal to x squared plus y squared. And then what are we looking for? The value of r, so we leave r. Substitute the x value, therefore it is minus 2, not positive 2, plus the y value, which is a minus 1 squared. Therefore, this r squared will give us a 2 squared, which is 4, minus 2 squared 4, plus negative 1 squared, which is 1. And therefore, r squared will be equal to 5. So our r value is equal to the square root of 5. And then grade 12, after calculating now all your values, you now have x, you have y, you have the value of r. We are going to put this in a specific block in which we are going to take while we are doing our calculations to answer our questions. Let's cluster now our information inside the box here. I'm having my data. What is my x value? X is minus 2. What is my y value? Y is minus 1. What is my r value? R is the square root of 1. Keep in mind that r is always positive. No? We do not consider r being negative. In all the quadrants, the r value will stay positive grade 12. Okay, there we have our values, and these values will only be applicable when your angle is alpha. After this organization of having your x, y, and r values, it is only then grade 12 that you can answer the questions given to you. So let's start with the first one. We are given sine alpha plus 4 sec alpha, and then we need to simplify this. Determine with the aid of the diagram the following ratios. All right, let's do so. Grade 12. This is equal to sine is what? It is y over r according to SOHCAHTOA, remember? And then we have the plus 4. And then the sec is what? Remember, sec is an inverse of what? Of cos. And remember, cos is what? Cos is x over r. And then if cos is x over r, its reciprocal will be r over x. There we are, grade 12. And then from here now we can start substituting. We just take from that particular box which will assist us. We are avoiding taking within the calculation because we can end up making mistakes then. So what is y? Minus 1. And the r value from our box, the square root of 5. And then we have a plus 4. And then the r value, square root of 5. And then the x value, it's a minus 2. And then basically grade 12, if we simplify this, it will give us an answer of minus 11 square root of 5 everything over 5. That is the expected solution for that. Okay. Okay, looking at 3.2. Okay, we have a cosec. If you have a reciprocal, you go back to original. Cosec, it was created out of the sine, or it is the reciprocal of sine. So sine is y over r, therefore cosec will be r over y. But in this case, remember it is squared. Okay. Sorry. Okay, thank you, grade 12. Sorry for that. We are back now. Okay, remember we were looking at the cosec. It's a reciprocal of a sine. Therefore, sine is y over r. So its reciprocal will be r over y. Since it is squared, it will also be squared. And then with the chord, remember the chord is reciprocal of a tangent. Tangent is y over x, so its reciprocal will take x over y. There is no square, you cannot add something which is not there. And then we can now substitute. Let's do so, grade 12. Our r value, square root of 5, and the y value, negative 1. This is squared minus 12 over 5. And then the x value is minus 2, and the y value minus 1. Easy now, grade 12. You just refer to your box there and take your data from that one. And then now let's look at the final answer there. This will give us 1 over 5. And then let's look at the mark allocation for the whole problem now. Number 1, you are going to receive a mark for indicating the correct quadrant. That is your first mark there, grade 12. Number 2, your second mark is for finding the value of r being the square root of 5. That will be your second mark. The third mark is to substitute in the first question, the substitution part, there will be your third mark. And then now finding the final answer. That means the first one will worth 4 marks. And then the second one also you'll get 1 for substitution and then 1 mark for your final answer, which is worth 2 marks. So basically this question will worth 6 marks for both questions. Okay, let's continue then. All right, let's have an activity and see how far can you go, grade 12, with this one. 3 minutes, starting now. It's your time to solve the problem. Okay, thank you, grade 12. Let's see how far did you go with this particular problem. Remember, we said our starting point, we always start from the given ratio. Okay, what is given to us is cos alpha, which is equal to minus the square root of 7/4. And then what is cos? Remember, it is adjacent over hypotenuse, which is x over r. That means we have the value of x there and the value of r being 4. So if you look at that, we short the value of y. So Pythagoras will assist us in that regard, but we can't go Pythagoras without a diagram. So we start with the diagram indicating which quadrant are we going to work in. Okay, right. Let's see. There you have your quadrant. And then you are looking at the cos that is negative, okay? Our cos in this case is negative. In which quadrant is cos positive? That means you need that cast diagram, grade 12. As you can see in quadrant 1, all ratios are positive, and in quadrant 4, cos is positive. So where is cos negative is quadrant 2 and 3. So basically, when you test your ratio, it will automatically always give you 2 quadrants. Then the restriction will cut off 1 quadrant there. So in this case, now we are looking at alpha is an element of 0 to 180. Look at this. We are moving from 0. Remember, this is 0, 90, 180 to 70 degrees up to 360 for one complete revolution. So if we are moving from 0 to 180, look at that, it lands us into quadrant 2. And then remember, we were targeting quadrant 2 and 3 in this case. That means this restriction simply cuts off quadrant 3 because we can only go up to 180. So this simply means now grade 12, our final diagram will be in quadrant 2. And then we are forming a triangle of 90 degrees there. And then put in the given values now. X is square root of 7. According to this diagram, you can see that this negative belongs to X. And then there's no way it can go to R because R is always positive, Rachel. And then now the R is equal to 4. So we need the value of Y in this case. So we can now go Pythagoras. We are looking at Pythagoras, which says R squared is equal to X squared plus the Y squared. Substitute the value of R. R is equals to 4 squared equals to the X value is minus the square root of 7 squared plus the Y squared because we are looking for Y. What is 4 squared? 16. Minus square root of 7 squared, it's positive 7 plus the Y squared. And then we transpose 7 to 16, then 16 minus 7 equals to 9. Therefore, Y squared will be equals to 9. And therefore, if this side loses an exponent, the 9 will gain plus minus the square root. And then what is the square root of 9? Y will be equal to plus minus 3 grade 12. This is actually giving us two values of Y, which is a positive 3 and a negative 3. So finally, you need to give us which one is the correct value of Y for this particular given information. According to the diagram, you can see that we are looking for the Y value that is positive. That means now we will now consider the Y being a positive Y. Now to cluster our information, grade 12, before we answer any questions from there, we have the X value, which is equal to minus square root 7. We have the Y value, which is positive 3. And then we have the R value, which is equal to 4. We can only use this information if our angle is alpha grade 12. And then now we need to answer the first question. Let's take this information into the next page there. We are having our X value previously as being the minus square root of 7. We have Y being positive 3. We have R being equal to 4. And then inside our box, we use this as only for alpha. Right, number 1, we were expected to look at cot alpha. Remember, cot is a reciprocal of what? Of a tangent. And then if tangent is y over x, its recip will be what? The x over y. And then how much is x from our data? Minus square root 7. And then what is the value of y? Equal to 3. That is the answer, grade 12. And then now let's look at 1.2. 1.2, we are given a tangent. Tangent ratio is y over x, but because this is having squared, this will also be squared. And then minus the cosec, remember it's a reciprocal of sine. And then what is sine? Sine is y over r. Therefore, its reciprocal will take r over y. Then after indicating the ratios, we can now substitute in the values. We have the y value from our data 3, and then the x value minus the square root of 7, all squared, minus the r value is 4, and the y value is 3. Okay, grade 12. And then if we square this bracket here, we end up with 9 over 7 minus 4 over 3. And then this will give us an answer of minus 1 over 21. And then the mark allocation, grade 12, you will be having 2 marks from Pythagoras diagram and the Pythagoras value of y that we have calculated. And then from the Pythagoras application, they're indicating the first correct quadrant, another mark on that quadrant, and then the third mark will be for that one. That means 1.1 will worth 3 marks, and then the second one will be for substitution, and then for simplifying and for answer, this will also worth 3 marks. Great jobs. I hope we are still together on that one. And then let's continue. And then we now move on to the reduction formula. And then with the reduction, great Charles, let's see. The reduction formula, we are working in our 4 quadrants. And then we know that in quadrant 1, we are moving from 0 degrees there. We go 90. We are counting anti-clockwise, okay? Remember, clockwise is when we go this way, the same way as your clock. But when we count quadrants, we count them anti-clockwise, starting from quadrant number 1, which is our quadrant 1 there. And then now we count from 0, we have 90. We have the 180 line, we have 270, and then back to that one, it will be the 360. We are revolving from 0, 90, 180 up to 360 revolution. And then how do we apply the reduction in this quadrant? So in quadrant 1, if I am in quadrant 1, you can see that I am less than 90. That is why I'm having a 90 minus there. So if I pass 90 now and move to quadrant 2, I am having a 90 plus, okay? But with you technical mathematicians, you don't use a 90 for your reduction. You also do not use 270 for your reduction. Your reductions only uses what? The 180 and the 0 and 360 there. So you reduce only with 180 and 360. All right. So when we are in quadrant 2, we are going to use what? 180 minus. When we are in quadrant 3, we will use what? 180 plus for that one. Because when you are in quadrant 2, you are less than 180. That is why we say 180 minus. When you are in quadrant 3, we have now passed 180. You are more than 180. That is why we say 180 plus. And then when we are in quadrant 4, we'll use reduction 360 minus, because when I am in quadrant 4, I am less than 360. I am going towards 360, but I'm less. That is why we use 360 minus. So when we go back to quadrant 1, we now use 360 plus, because we are revolving for the second time. It's where we'll be having angles of 480 and so forth, grade 12. That is beyond the first revolution of 360, which is more than 360, revolving for the second time. Remember, one revolution is 0, 90, 180, 270 up to 360. That is one revolution. And then now with our cast diagram, we've already talked to this, that we'll be having a cast diagram, which means all ratios in quadrant 1. This A stands for all ratios in quadrant 1 are positive. The sine with its converse cosec, the cos with sec, the tangent with the cot, they are all positive in quadrant 1. And then in quadrant 2, sine is positive, as you can see there. If sine is positive, that means also cosec will be positive in that quadrant. And then the cos and sec is negative, tan and cot are negative in that one. In the third quadrant, tangent is positive, and then if tan is positive, also cot will be positive because it's reciprocal. And then the sine and cos will be negative together with its reciprocal in quadrant 3. Quadrant 4, we are having a cos positive, as indicated there. So also a sec will also be positive in that quadrant because it is its reciprocal. So sine and cos will be negative together with its reciprocal. That is the purpose of reduction, grade 12. Quadrant 2, 180 minus, quadrant 3, 180 plus. Quadrant 4, 360 minus, quadrant 1 again is where we are having more than 360, which is 360 plus. Basically, we will be using those reductions. Okay, let's have this small activity with you and try to apply the information given to you previously. Right, we are now in second quadrant. We are talking this quadrant here, grade 12, second quadrant, okay? And then now where we are having reduction 180 minus. So let's test now. We are having sign 180 minus. So the 180 minus here is indicating the quadrant. Which quadrant is that one? It is quadrant 2 where we are having 180 minus. After identifying the quadrant 180 minus, you check, is sign positive in that quadrant? Yes, it is positive. Therefore, we end up with the sign theta, which is positive. We are now reducing our angles to theta in this case, okay? And then still in quadrant 2, let's see now we have a cos of 180 minus. Yes, it is still in quadrant 2 because we are in 180 minus. How is cos in that quadrant? Cos is negative, therefore it will give us a minus cos theta. This will be reduced to theta now. That means basically grade 12, this 180 minus is used to identify the quadrant. After identifying the quadrant and checking the sign of your ratio, you don't need that 180 minus anymore, okay? Then we have 180 minus quadrant 2 still. How is tan in that quadrant? Tan is negative, so we end up with a minus tan theta. Basically, that is how we use the reduction formula. Moving to quadrant 3. What is quadrant 3? It's where you are having reduction 180 plus. Okay, and then in quadrant 3, let's check now. If I'm having sign in quadrant 3, how is sign? Is negative. It is still a sign, but of what? Theta now, because we are done testing 180 plus, which is quadrant 3. 180 plus quadrant 3. How is cos in there? Cos is negative, therefore it's minus cos of theta. Still in 180 plus quadrant 3. How is tan in there? Tan positive, therefore we end up with tan theta being positive. Grade 12, that is how you reduce your angles, all right? And then in the fourth quadrant, we are having reduction 360 minus. And then now sine in quadrant 4. How is sine? Is negative. Therefore, we end up with minus sine theta because 360 minus was indicating the quadrant. And then cos in quadrant 4. And then the cos is positive then. Therefore, this will be positive cos theta. Okay, grade 12, this was supposed to be tangent. Okay, that is tan negative. All right. And then from here now, how is tan in quadrant 4? The tangent is negative. So we end up with minus tan theta there. So basically that is what we mean grade 12. As we can see that in quadrant 2, sine is in charge. Sine is in charge. In quadrant 3, that is tangent positive, tan is in charge. Quadrant 4, cos is positive there. Quadrant 1, all ratios are positive. Okay, moving on. We have special angles that we will be applying also with reduction formula. Which angles are special now? We are talking to the 30 degrees angle, the 45 degrees, and the 60 degrees grade 12. You can use this particular table here, or you can use your scientific calculator. It will give you those values, okay? And then if you are having the 30 degrees, that means your x will be square root 3, and then your y1, your r is 2. With 45, the x is 1, the y is 1, the square root of 2. And then with 60, we have x1, y square root 3, the r is equal to 2. And then now, as you can see now, this 30 is now also written in radians then. So on the next activity, I will show you how do you change this 30 into radians grade 12. But 30 degrees is basically equal to 1/6 radian. And then 45 degrees is equal to a quarter radian. And then the 60 degrees is equal to a 1/3 radian. Okay. And then now we also need a unit circle. Unit circle is where you are having this particular circle here, which is cutting x at 1 and minus 1, and the y, as you can see, at minus 1 and 1 there. Okay, we also need values around that. If you are looking at the cos of 360, that means the cos will be on that particular line. That means the value will be equal to 1 of that particular cos, going on like that. And then grade 12, You can verify this using your scientific calculator. It's not a trace mesh. When to use a unit circle, it's when your angle is on this particular line. When it is an angle of sine 90, a cos of 180 or cos of 360 and so forth, it's only then that you apply that unit circle. Your calculator can also assist you on finding those particular values. Okay, and then now we have a small activity here where you are converting degrees to radians or a radian to a degree. And then to convert an angle from degrees to radians now. That means that angle must be given in what? In degrees. How do you change that? Basically, grade 12, we know that a radian is equal to what? 180 degrees. 1 radian is equal to 180 degrees. So in a Cartesian plane, that means if I don't want to write 180 here, if I want to write this in radians, I will have a radian there. If I don't want to write 90 degrees here, I will have what? A half radian and so forth. Okay? So now how do you change these degrees into radians, grade 12? You look at your problem. If I am having a degree, let this be over 1. You can see that the degree is on top there. So you multiply by a radian over 180. Degree on top, 180 degrees must be on the denominator now. And then this will give us what? Which is 1 over 6 radians there. So 30 degrees is basically 1 over 6 radians. Remember, we have indicated that lastly when we were looking at the special angles there. Okay, changing what? To convert an angle from radian to a degree now. You multiply the radian by 180 over radian. Now we have 1 over 3 radians there. Then we want to change this into degrees. How do we do that? We use the same 180, but be careful now. Since the radian is a numerator, radian must be a denominator there. Okay, so it is 180 over a radian, and then this radian will cancel a radian. You are left with 180 over 3, which is equal to 60 degrees. Therefore, grade 12, basically the radian, 1/3 radian will be equal to 60 degrees. From degrees to radian is the radian over 180. Okay, from radian to degrees is 180 over a radian. So that is how you change them around. Right, let's have the first example now on reduction. Okay, this is supposed to be a tangent. All right, and then given that the cos of radian plus theta and the tan multiplied by tan of 360 minus theta and the sine of 180 minus theta, then simplify firstly the cos of a radian plus theta. Remember, grade 12, we've indicated initially that what is a radian? A radian is equals to what? 180 degrees. In this case, it is plus theta. Now we have a reduction notation there. We need to check in which quadrant. We are in quadrant 180 plus. Which quadrant is that one? You can see that is quadrant 3. Okay, so how is cos in quadrant 3? Cos is negative, so this is giving us a minus. Cos reduced to theta now. Okay, and then now hence simplify this particular reduction type question. So cos radian plus theta we have already simplified. We'll write it as minus cos of theta from the previous answer there. And then multiply. Please do not use a dot, use a multiplication sign because it will confuse you if you bring in a negative. And then we are looking at which quadrant now? 360 minus, we are in quadrant 4. How is tan in that quadrant? Tan is negative, therefore we end up with minus tan reduced to angle theta then. And then denominator, which quadrant? 180 minus, we are in quadrant 2 then. How is sine in there? Sine is positive, so we end up with the sine of theta, grade 12. And then from here now, we have an identity of tangent. Identity tangent indicate that a tan theta is equal to a sine theta over there. cos of theta. So we are going to change this tangent into that particular identity. So we have minus cos theta multiplied by negative. What is tangent? Tangent is sine theta over the cos of theta. Remember, we have that denominator sine theta. So cos will cancel a cos there because this is cos over 1. This denominator cancelling the numerators, okay? But when only we are multiplying great 12. And then the negative times the negative is a positive. So on top we'll be left with positive sine theta. And then denominator we are left with the sine of theta. So sine theta divided by sine theta, it will give us a 1. It's not a 0 great 12. Sine into sine goes only once. And then when looking at the mark allocation for this particular problem, we'll be having 1 mark for indicating that a radian is 180 degrees there. 1 radian is 180. Second mark for simplifying that into a single ratio there, or reduced ratio. 2 marks for that particular problem. Okay, basically this will worth 2 marks there. And then now number 2, a first mark, grade 12 in reduction part, it's where we are collecting marks. You ensure that you have checked the sign in the quadrant and it is the correct sign. So we have minus cos, that will be your first mark. The second mark will be minus tan, reducing that to minus tan theta. The third mark is for sine theta. For that particular step, you will be having 3 marks for that one. They can even omit that mark because they have already allocated a mark previously for that one. So this will be 2 marks. And then for changing a tangent to sine over cos, that will be your third mark. For simplifying fourth, and then this can worth 4 to 5 marks, depending on the examiner. Okay. All right, example 2 now. Look at this type of reduction. We are still on reduction. Previously, we were having angles in terms of x, in terms of theta. 180 plus theta, or 180 minus theta, 360 plus theta, and so forth. And then now we are looking at the type 2 of reduction, where we are given now our angles in terms of specific values of angles. Let's see grade 12. So how do we deal with this one now? Right, number 1. We have 4 sine, and then we check 150 degrees. If I'm revolving around my quadrants there, I know that in order to have 150, I must be in quadrant 2, just before 180, because 150 is less than 180 degrees. And then if I'm in quadrant 2, which reduction is in there? 180 minus. Or therefore, I will be using the reduction 180 minus because I'm in quadrant 2. Okay. And then how much must I subtract to end up with the 150 originally given to me? I must subtract a 30 degrees there. Okay, done with the first reduction. Let's look at the second one. I am having cos of how much? 210. We need to locate this 210. In which quadrant is 210? I'm moving 0, 90, 180, 210, quadrant 3. Before the 270, therefore it is in quadrant 3. What is the reduction in that quadrant? I'm having 180 plus, therefore my reduction will be cos of 180 plus. How much must I add to get a 210? I am adding a 30 then. Do you see how important is this table, grade 12? The reduction in 4 quadrant, you really need that in front of you before you start solving this. And then lastly, we look at the tangent on the numerators. The tan of 300, I am now locating 300, 0, 90, 180, 270. I can see that I'm landing in quadrant 4. What is reduction in quadrant 4? 360 minus. Okay, therefore I'm going to use the tan of 360. How much must I subtract to get 300? I must minus a 60 then. And then on the denominator, I am having a cos of 180. Can you see that this one is a unit? Because it's on the axis. 180 is on the line. Therefore, I am going to look at the unit circle, or you can use your calculator. And then 180, you look at that is on the -1 on the unit circle. Therefore, my cos will be a -1. Cos of 180 will give me -1 according to the unit circle. Okay, let's continue grade 12 now. We are reducing this to an angle that is less than 90 degrees now. This will be 4 sine. Look at this, 180 minus was giving us a quadrant, which is quadrant 2. How is sine in that quadrant? Sine is positive, therefore this ratio will remain positive. So this will be 4 sine of 30. Now we are done with 180 minus, okay? And then multiply 180 plus, let's look at that. 180 plus quadrant 3. How is cos in that particular quadrant? Cos is negative. That means this will give us a minus cos. Now reduce to what? To 30 degrees. Multiply by. We are looking at 360 minus. Which quadrant is that? Quadrant 4. How is tangent in that quadrant? The tangent is negative. Therefore, this will give us a minus tan of what? 16. Reduce to 60 now. And then divide. Remember, we have a -1 on the denominator there. And then we have now, if you look at this problem, has now created special angles. Remember, 30, 45, 60, those are special angles. Your calculator, Casio Sharp calculators will assist you to get those values, okay? And then if you are looking at sine 30 is equals to half. Multiply by negative, the cos of 30 is square root of 3 over 2. Multiply by negative, the tan of 60 is square root 3. And then we have everything over -1. Okay, let's continue grade 12. And then the half of 4 is how much? We are having a 2 there. Multiply by a negative times a negative will give us a positive. And the square root 3 multiplied by square root 3 will give us a 3. And then over 2 from 3, square root 3 over 2. Remember, this is divided by -1. And then the 2 will cancel 2 because it's 2 denominator, 2 numerator. And then we end up with the 3 on top and then -1 denominator. Our answer will just be a -3 grade 12. So that is the second type of reduction. Okay. There you have your activity grade 12. 5 minutes on that particular activity. Start your 5 minutes, starts now. Okay, grade 12. Let's see how far did you go with this particular problems, right? Starting with 1.1. Okay, remember you can't solve this without having your Cartesian, remember? Okay, of which is going to tell you whether you are 360 minus or 360 plus, 180 minus or 180 plus, whether you are positive or negative in that particular quadrant. That is a cast diagram. All ratios are positive in there, sign positive, tan positive. Let's see now. Okay, we are using reduction. We need to reduce these angles to a single ratio there. Okay, then we have sine 360 minus 360 minus, which quadrant is that? That is quadrant 4. Okay, how is sine in there? As you can see, sine is not there, therefore it is negative sine x multiply 180 minus, let's see, less than 180, we are in quadrant 2. And then in quadrant 2, how is cos there? It's only sign that is positive. That means cos you are supposed to be negative. Multiply 180 minus, let's see, where are we? 180 plus quadrant 3. How is tan in that quadrant? Yes, tan is positive. Therefore, we'll end up with the tan of x. Divide by cos squared, we leave this one because there is no reduction on that one, and then multiply by 5/6 radians, grade 12. Remember now, if it is radians, you become confused. You don't know which quadrant are you working in. So we are going to change this 5/6 radian into degrees. Remember, if it's a radian, it will now be 180 degrees multiplied by 180 degrees over radian. Then a radian will cancel a radian, and then this is giving us how much? 150 degrees. That means basically this part here, it is sine of 150 degrees. And then if we write this in a reduction form, that will be the sine of what? 180 minus 30, because 150 is in quadrant 2. So in quadrant 2, you have 180 minus. How much must I subtract to get a 50? I am subtracting a 30. Okay, and then let's continue now. And then I see a tangent there. Tangent, easy way is to change to its identity, sine over cos. Let's do so. We have a minus sine x multiplied by minus cos x multiply identity sign, that is sine x over the cos of x, everything over cos squared x multiply. So 180 minus sine 180 minus, we said 180 minus is quadrant 2. And then how is sine in that quadrant? Sine is positive. Therefore, this will remain positive sine reduced to 30 degrees now. Okay. And then on the numerator here, we can see that we have cos numerator and then cos denominator, and we are multiplying. So we can cancel those two. Simplify by cancelling. And then you have a negative times negative, which is positive. So we are having sine here multiplied by sine, which is giving us the sine squared x. Denominator is over 1, so we can leave that one. And then have a cos squared x multiplied by sine 30 is now a special angle, right? And then the sine of 30 is giving us how much? Half, according to the special angles values. All right. And then now grade 12, if you look at this part here, this is the tangent identity, sine over cos, which will give us a tan squared x. And then this is now divided by half, and therefore this is the same as tan squared x multiplied by 2. So we end up with 2 tan squared x as our single ratio there. Allocation of marks will be minus sine x, minus cos x. The tan x is the third mark. And then the fourth mark will be changing this radian into a degree. That will be your 4th mark. The 5th mark is for reduction to 30. And then the 6th mark is to change in tangent into sine over cos. And then the last mark will be for the answer. So this can worth up 7 or 8 marks, grade 12. So reduction worth many marks in your trigonometry. Please ensure that you understand, you double check the signs on the quadrant. And then we are having cosec of 180 plus theta. Remember, we still need that cast diagram. And then we have 180 minus 180 plus 360 minus and 360 plus 10. And then now remember, cosec goes with the sign. And then that means where sign is positive, cosec will also be positive. Right, let's check now. We are having 180 plus. That is quadrant number 3. How is cosec in there? Cosec in here is negative because cosec is only positive where sign is positive. So when it is in quadrant 3, therefore this will be negative cosec theta. Multiply. We have 360 minus, that is quadrant 4. How is sign in there? Sign is negative, then it's minus sine theta. Then we have a negative sign there, and then we have our bracket. Inside the bracket, we have a sign of 180 plus theta. 180 plus quadrant 3. How is sign there? Negative sine theta. And then we have a reciprocal sec 60. Remember, the sec is a reciprocal of what? Of cos. So we can write this exponent as 1 over cos 60 then. Okay, let's continue, grade 12. And then now we have minus cosec theta multiplied by minus sine theta. The easy way to solve trick is to change everything into sine and cos. Can we change cosec into cos? Yes, we can write it as 1 over sine because it's a reciprocal of sine. So this will give us minus 1 over the sine of theta multiplied by minus sine theta minus into the bracket. We cannot multiply the negative in because we have an exponent there. Then it will remain minus sine theta here. And then 1 over cos 60 is giving us 2. And then continue to the next step, grade 12. And then now look at this now. We are multiplying only for this part. We are multiplying. Numerator sign cancel the denominator sign because of multiplication. And then negative times negative, it's a positive. So these two ratios here are giving us 1. Okay? And then we have a negative, which is from here. And then negative sine theta squared will give us a positive sign. Because it's a square identity, it will be a square theta there. And then what is 1 minus sine squared? According to our trig identities, this will give us a cos squared theta, grade 12. So that is a single ratio simplified to that. Mark allocation will be for reduction 1, 2, 3. And then number 4 for writing the reciprocal of that. And then number 5, the reciprocal 6 for cosec. And then now for evaluating that 1 over cos is 2, 7. And then now for the simplification up to the answer, which will worth 8 marks. Can you see, grade 12? These types of questions, they worth so many marks. And then now last activity solution. Right, we are having, remember, we still need that cast diagram throughout the reduction solution. We have 360 minus plus 180 minus plus. That is all we need. And then now tangent 408. Can you see this 480 now is more than 360? That means you have revolved for the first time. We are now revolving for the second time. If your value is more than 360, grade 12, just subtract a 360. So we will say 480 minus the 360. That will basically give us what? 120 here. That means we are actually dealing with the tangent of what? 120 degrees. And then 120 is in quadrant? Quadrant 2. So this will give us what? The tan of 180. How much must I subtract to get 120? 60 degrees. Multiply. Sine 300, quadrant 4. What is the reduction there? 360 minus. Okay, then I'll be having a sine of 360 minus. How much must I subtract to get 300? Subtract 60 degrees. Continue. I'm having a sine of 135. 135 is in quadrant 2. What is the reduction there? 180 minus. And therefore, I'll be having a sine of 180 minus, how much must I subtract to get 135? A 45 degree. Okay, all over. And then the cos of 225, that is in quadrant 3. Okay, when I'm in quadrant 3, I'm having the reduction 180 plus. Therefore, this will be cos of 180 degrees plus what to get 225? Plus 45 grade 12. There we are. As you can see, now we have created the special angle 60-45. Okay, now we check the quadrant, the sign of the ratio in that particular quadrant. First one, we are in 180 minus, that means is quadrant 2. Is tan positive or negative? Negative in that quadrant. There we end up with minus tan 60 degrees multiply. 360 minus which quadrant is that? Quadrant 4. Sign in that quadrant is negative. So we end up with minus sine 60 degrees. Multiply. Sine 180 minus which quadrant? Quadrant 2. How is sine in that? Positive, because it belongs to sine that quadrant. Therefore, it will be positive. Sine 45 degrees. Sine is the owner in that particular quadrant. And then cos 180 plus, that is quadrant 3. How is cos in there? Cos supposed to be negative. Cos 45 degrees in quadrant 3. So everything is now reduced grade 12. It has now created special angles. We can now look at the special values. For tan 60, we are having the square root 3 multiply minus. For sine 60, we are having square root 3 over 2 multiply. For sine 45, we are having the square root 2 over 2 divide by negative. For cos 45, we are having square root of 2 over 2. Therefore, we can cancel the square root of 2 by the square root of 2 because it's all multiplying and dividing there. Okay. And then the negative multiplied by negative on top will give us a positive. The square root 3 multiplied by square root 3 there. Remember, this is over 1. Square root 3 multiplied by square root 3 will give us a 3. And then 1 times 2 there will give us a 2. And then remember, we are dividing by negative 1 remaining on the denominator there. So our answer will just be a negative 3 over 2 for that particular problem. And then mark allocation will be for reduction 1, second reduction, third reduction, the fourth reduction. And then the fifth mark will be for substitution in all special angles 5. And then the simplification will be 6 marks for that particular problem. Okay, then we are done grade 12 with the reduction. Moving forward to trigonometric identities application now. How do we solve using them? Okay, we are having the trig identities. The first identity, we have already used this one. Tan is sine over cos. Okay, and then cot, remember it's a reciprocal of tangent. It will take the reciprocal also. If tan is sine over cos, cot will take cos over sine. And then we have identity, a square identity. Sine squared plus cos squared equals to 1. In order to apply this grade 12, this must have squares. Without squares, it cannot be equal to 1. For an example, if I'm having a sine theta plus cos theta, this is not equal to 1. It only works if it's a square. That is why we say these are square identities. They only work with squares. Okay, it's only tangent and cot that does not need squares to be applied. And then now we can play around with this one. Let's say you decide to leave sine on the left. We are transposing cos to the right, so we'll end up with 1 minus cos. That means where you are having sine squared, you can remove and write 1 minus cos squared, and then vice versa. So And then the cos squared, let's say maybe you decide to leave cos squared, you transpose sine, you'll end up with 1 minus sine squared. The same way, where you have a 1 minus, you can remove and write the cos squared, grade 12. And then now the second squared identity, we have 1 plus tan squared, which is equal to the sec squared. Same way, you can leave the tan squared on the left and transpose 1 to the right, then you'll end up with sec squared minus 1 there. Or you can take tangent maybe to the right, and then if you transpose a tangent, you will have a sec squared minus tan, and then you take negative 1 to the left, so it will give us a 1. This is basically telling us if I'm having a sec squared minus the tan squared, this is equal to 1. I can just substitute a 1 for that. The last squared identity, we have 1 plus cot squared, which is equal to a cosec squared. So I can remove 1 plus cot squared and write a cosec squared. And then now I can also play around with this, transpose the 1 to the right hand side, and I will be left with cot squared. This one becomes negative 1 when it moves to that side. The same application now, I can decide to take a cot to the right. If cot is taken to this side, then I will have a cos squared, cosec squared theta minus cot squared theta. So I will be left with the 1 on the left. Basically, grade 12, this simply states that if I'm having cosec squared theta minus cot squared theta, I can just write a 1. And can you see now those ones? We are having sine squared plus cos squared equal to 1. Sec squared minus tan squared equal to 1, cosec squared minus cot squared theta equals to 1. Those are the identities. Remember, the square identities, they work only if you have a square. Right. Let's take an example then where we are applying our identities. Prove the following identity. Lucky enough, grade 12, if it's a proof question, the answer is given to you. So we are given the left-hand side, but our answer is given as being the cot squared x there. Yours is to simplify what? Your left-hand side and ensure that you get the answer cot squared x there. Okay, let's see how do we do that. The simplest way of dealing with the proving the left-hand side, try to write everything in terms of sine and cos. It will make your life easier. Okay, now let's go back to cot. Remember, cot is a reciprocal of tangent, and the identity tangent is sine over cos. So if it is a cot, it will be a cos over sine now. So this will be cos x. Since it is squared, this will also be squared, grade 12. It will be cos squared x over there, sine squared x for a cot. Multiply. All right, then I'm having now a sec squared. How can I write sec in terms of sine and cos? Remember, a sec is a reciprocal of a cos. Therefore, this can be written as 1 over cos, all right? Since it is squared, it will also be 1 over cos squared x minus. We have an identity which says that sine squared plus cos squared is equals to 1. So we are just going to put a 1 for sine squared plus cos squared. We are still on the left-hand side. We are multiplying denominator cos squared x, numerator cos squared x can cancel. So we will be left with 1 over the sine squared x minus 1. What is 1 over sine squared, grade 12? Remember, it's a reciprocal for the cosec squared x minus 1. According to the identities indicated above, remember we indicated that the cosec squared minus 1 is the same as what? As the cot squared x. That means now, therefore, our left-hand side is equal to what? The right-hand side. We have simplified this using our identities. Okay, let's take the second example. Again, on identities, we are having a sine squared. Look at this, we have sine squared and the cos squared. And then our expected answer here, it must be just a 2. Okay, we are going to deal with the left-hand side and simplify until we get a 2. But we are targeting, we have something here which is saying sine squared beta. I'm going to just bring closer the cos squared b there. Then I will be having plus this part here. And then the tangent, it can be the sine beta over the cos beta identity multiplied by the cot. Remember, cot will take the inverse of this, which is cos beta over the sine of beta. Can you see grade 12? What we are having now? We have a sine squared plus cos squared, which is equals to 1. And then now from these two, sine will cancel a sine, the cos will cancel a sine as a cos. Because we are multiplying, numerator can cancel denominator. So this cancellation is giving us a positive 1. And then 1 plus 1 is giving us a 2. Okay. Alternatively, grade 12, or you can bring closer sine squared beta plus cos squared beta, and then plus for the tangent and cot there, you can leave a tan beta, multiply and change the cot to its reciprocal, which is 1 over the tan of beta. Okay, so we are multiplying here. The tan will cancel a tan there, numerator denominator multiplication, and therefore this sine squared plus cos squared will give us a 1 plus a 1 from that cancellation. Therefore the answer is also equals to 2. Conclusion, the left hand side is equal to the right hand side. And then the mark allocation here will be for changing here 1, and then for noting that the sine squared plus cos squared is equals to 1, for simplifying, getting a 1 and the answer there. That means this problem is worth 4 marks there. Okay, great chance. Let's have an activity. There you are. Let's spend 5 minutes on that and then reflect back. Okay, grade 12s, let's see how far did you go with these particular problems. Let's look at 1.1. We are having the cot squared 2b minus the cosec squared 2b. So now, remember this is an identities. Remember these identities, you'll find them in your formula sheet at the back of your question paper. Don't stress about anything. You'll just refer and take out those identities. The identity for the cot squared, it can be written as the cosec squared, because your angle is 2 beta. This will also take angle 2 beta, and then this will be minus 1. This is representing a cot squared 2 beta. And then we have bring down the minus cos square cosec squared 2 beta. Okay, and then can you see that the cosec squared 2 beta will cancel the cosec squared beta because we are subtracting? Then your answer will just be a minus 1. Or alternatively, you can decide maybe to change the cosec squared and take the identity which says that the cosec squared is equal to the 1 plus cot. Okay, on the same note, we are now on. Let's take the problem. We have cot squared 2 beta minus the cosec squared 2 beta. Let's say you decided to change that one. So you leave a cot square 2 beta minus, you now change the cosec to identity 1 plus the cot square 2 beta. Then this will be cot squared 2 beta brought down, and then we multiply a negative in. We put a bracket because we are now having two items there. So this negative will affect both of them. That will be minus 1 and minus a cot squared 2 beta. Then the cot squared 2 beta minus the cot squared beta, it will be just a negative 1. So that is how you simplify that. So the first mark will be taking the identity, the second one for the answer. So in whichever way, it will be for the identity and then for the mark for simplification. So this problem was 2 marks. Okay, 1.2. All right, look at that. We have radians then. That means you need to deal with those radians to simplify this problem. And then we can write a tangent with the identity sign, because there's a square, it will be sine squared over cos squared A for tangent. Multiply by cosec, remember it's the reciprocal of sine, then it will be 1 over the sine squared A. And then minus the cos of 2 radians. Remember, if you change radians, we are multiplying with 180 degrees over radian. Radian. So 2 times 180 will give us a 360 degrees. Therefore, here we are looking at the cos of 360 degrees. Okay, the sign, denominator, numerator, because we are multiplying, you can cancel. So you will be left with 1 over the cos squared A, and then the minus cos 360. Remember, it's on the Cartesian plane, is that line here where we are having unit 1 according to the unit circle. Therefore, the cos of 360 is 1. What is 1 over cos squared? Remember, this was a reciprocal for the sec squared A minus 1. And then identity sec squared minus 1 is equal to the square identity, which is tan squared A. So this is the single ratio for that particular solution. So your first mark will be for identity sine over cos for a reciprocal. For changing radian is the third mark. And then now from here, for writing cos 360 as being 1, that's the fourth mark. For changing 1 over cos to sec 5, and then this final answer. So this problem can worth 6 marks, grade 12. And then now, trig identity. Now we are looking at proof question number 2. We are given the left-hand side and the right-hand side. It's up to you, grade 12, which side you choose, because you can't tell whether should you choose right or left, because these sides, they look equal. Remember, in the previous problem, we only have one value on the right. It was easier for us to decide which side to select. Let's say now you've decided to take the left-hand side. So if you take left-hand side, you're expecting our answer to be sec x minus the cos x. And then now the left-hand side, you're having the tan of x multiplied by sine of x. What is tangent? Remember, tan is identity sine x over cos x multiplied by sine x. Correct? And then from here now, remember we need a sec. In order to be a sec, let's multiply on top. We have sine squared x over the cos x. Okay? And then from here now we can have the sine squared x can be written as 1 minus cos, because we want to create that cos on the left, okay, on top. That means this 1 sine squared can be written as 1 minus the cos squared x from the identities, and then denominator we have the cos of x. Now we are going to separate each numerator to k to take the denominator now back to its LCM. Therefore, this will be 1 over cos x minus the cos squared x over the cos x. We have now splitted this into its original LCM, okay? And then what is 1 over cos? Remember, it's a reciprocal of sec. Then this will be sec x minus 1 cos will take 1 cos, then you are left with only cos x. Can you see that the left-hand side is now equal to the right-hand side, great chance. Alternatively, so one can decide to take the right-hand side instead of the left-hand side. If you take the right-hand side now, you are going to change this sec into its reciprocal, 1 over cos x minus the cos x. Remember, this is over 1. And then you look at the LCM of the two, that will be the cos x there. Apply the LCM method, cos cancel, cos times 1 will end up with 1 there, minus 1 into cos, 1 cos times cos will be cos squared x. And then what is 1 minus cos squared x? That is the same as sine squared x identity over the cos x. Okay? And then from here now, we can have a sine x over the cos x. I've separated this 2 sine here. I'm splitting it into sine x, so that I can have a tangent there. Can you see that? That is sine over cos, which is tan x, multiplied by the sine x. Can you see that is your left-hand side? Therefore, the left-hand side is equal to the right-hand side. Sometimes it also works grade 12 by choosing the right-hand side. You must choose wisely when you are doing that. Okay, grade 12, this brings us to the end of today's presentation. And then this was brought to you by the Gauteng Department of Education in collaboration with Scibono Discovery. And then it was broadcasted by Phakama Research and Development. Thank you very much, grade 12, for your cooperation, for preparation for today's session. And then see you next time on our next session. That will be on the 11th of May. And then the topics that will be treated will be trig functions with 2D and 3D. See you then, grade 12. Thank you very much.